Okay, lecture 9, composition of functions. So we'll do definition and a couple of memes that I found that I thought were funny. Composition with formulas, composition with tables, and decomposition. So a composition of two functions, g followed by f, means to take the outputs from g and use them as the inputs for f. This is written either f circle g of x, or f composed with g of x, or f of g of x. So the idea is that we have a function f of x and another function g of x. We take the g of x and you stuff it in where that f is, stuff it in where the x is to get f of g of x. So one way to think about it is we've got a big box for a function. And inside this box, we've got two smaller boxes. So what we see is we see that, I don't know what these are. I'll call these apples go into the big box and oranges come out. And that's the function f of g of x. Because what's happening inside the box? Well, the apples come in and they get fed into the g function, and the g function takes apples and turns them into lemons. Boop. And then the lemons enter the f function, and the f function takes lemons and turns them into oranges. So what's going on inside the box is actually, you start with an apple, gets turned into lemons, you don't see the lemons, and those get turned into oranges and you get oranges out. So f composed with g of x is the entire function that takes apples and turns them into oranges. And this is a intermediate function, intermediate variable. It's often called u when used in algebra text. Another way to think about this, and I like this meme, I like the math memes sometimes, right? F of g of x is pineapple, f of x is pizza. So pineapple on pizza looks like this, but pizza on pineapple looks like that, right? So it matters which order you put things in because, well, I don't particularly like pineapple on pizza, to be honest. So I should have done this with pepperoni and pizza, but yeah, I would go with a pizza with pineapple on it rather than a pineapple with pizza on it. It'd have to be a pretty darn big pineapple. Anyway, so the idea then is that we've got two different functions that do two different things, but we can chain them together so the output from one just gets fed into the next. So composition with formulas. So f of x is this, g of x is this. What's f of g of 3? So that means I'm taking 3 and I'm putting it into a big box. And I want to have come out a number that's f of g of 3. And inside there, I have two functions, g first and f second. So my 3 comes into the g. G of 3, that just means take 3 and plug it in for x into g. That's square root of 3 minus 2, that equals 1. So g spits out 1. And then we take that 1 and we just run it into f, and f is this function. So we take the 1 that came from g and we run that into x, f of x, and we get f of 1 is absolute value of 1 minus 1 plus 2, and f of 1 equals 2. So that means 2 comes out of this function, and since we don't have a third function to put everything through, 2 is our output. So f of g of 3 means take 3, run it through g to get 1, take 1, run it through f to get 2, and that's our output. So g of f of minus 8, what does that mean? It takes minus 8 and run it through f. So f of minus 8 is minus 8 minus 1 plus 2. So that means I've got a minus 9 inside my absolute values plus 2. So f of minus 8 equals 9 plus 2 equals 11. And I take that 11, and that's my f of minus 8. So we take g of 11 because that's the output, and that's square root of 11 minus 2, which is square root of 9, which equals 3. So g of f of minus 8 equals 3. Take the minus 8, put it into f, you get 11. Take the 11, put it into g, you get 3. So formulas and domains for this. Let me write down what f of x is again. F of x is absolute value of x minus 1 plus 2. G of x is square root of x minus 2. So what are the formulas and the domains of this? So f composed of g with x, that's this thing, is f of g of x. And so that means I want to replace the x in the function for f with the formula for g of x. So the absolute value, take the x and replace it with this formula. And then we still have the minus 1 inside plus 2. And there's not much you can do to simplify that. That's just what it is. What's the domain? Well, the thing inside the square root has to be positive. So, or 0. X has to be greater than or equal to 2. So that's the domain for that. So that's pretty straightforward. G composed with f. That means I'm taking G and I'm putting f of x inside of it for x. So we'll take G, which is a square root. I'm going to take the formula for f of x and plug it in for x. So I get x minus 1 plus 2, and then I have this minus 2 that's part of g of x. That I can simplify a little bit because 2 minus 2 is 0. So square root of absolute value of x minus 1. Domain, well, it's a square root. So to think about the domain, I need the thing inside the square root, which is absolute value of x minus 1, to be greater than or equal to 0. But absolute value of anything is always greater than 0. It doesn't matter what number you give absolute value, it's always going to give you a positive number or 0. If we set x equal to 1, you get 0 out of that. So doesn't matter what x is. Whatever x is, the thing inside the square root will be positive, so the domain is all x or minus infinity to infinity. So just because it's a square root doesn't necessarily mean that the domain is restricted, right? I mean, here, the thing we put inside the square root is always positive or 0, so there's no problem with the square root. So what's g of x? That's, well, we're taking the formula for g of x and we're going to put it inside of g of x. So that means we want to replace the x here in the formula for g of x by this whole formula. So it's square root of x minus 2 minus 2. What's the domain of that thing going to be? Well, this is the thing inside the square root. So we need the thing inside the square root, which is square root of x minus 2 to be greater than or equal to 0. Or square root of x minus 2 to be greater than or equal to 2. So what is the x for that? Well, we can square both sides. And we want x minus 2 to be greater than or equal to 4, or x greater than or equal to 6. So as long as x is bigger than 6, that means this square root, we can do the square root because x is bigger than 6. So we get something positive inside of this square root. And if x is bigger than 6, then whenever we take this square root, we'll always get something bigger than 2. So that means that when we subtract 2 from it, we'll get something in there. We'll get a positive number inside of my square root. So it takes a little work sometimes to figure out what domains are. They're not entirely obvious, especially when we start nesting functions inside of each other. So tables, f of x and g of x are defined by these tables. What are these various things? So again, g composed with f of 2. This is g of f of 2. That means we start with 2, we put it into f. So we start with 2 and we put it into f, and that gives me a 2. So f of 2 is equal to 2. And then I say, well, take that 2 and run it through g. And that gives me out a 4. right? So 2, f turns 2 into 2, take that 2, run into g, g takes a 2 and turns into 4. F of g of 1, so this is f of g of 1. So we start with 1 on the g table, that's here, that goes to 5. We take that 5 and we plug it into the f table, and that gives us back a 1. This is equal to 5, and then we use that in the f table. This is equal to 2, we use that in the g table. What's f composed with f of 5? F of 5. Well, you start with 5, run it through f, and you get 1. So this is going to be f of 1, since we figured out that this is 5. And we go back to the f table again and plug it into 1, get out -1. And finally, what's f of g of -1? Well, we go to the g table, we look up -1, and that's -1. And then we go to the f table and we look up -1, and there's no -1 in the domain of x. Does not exist. So -1 is not in the domain of this composite function because there's no -1 for f of x. So what are the tables for the compositions? So if we have two functions defined like this, and I think it's the same, 3 - 1, 4, 5, 4, -1, 2, 1, 2, 1. Yeah, those are the same as above. What's the composition table? So G composed with F. This means doing F first and then G. So 1 goes to -1, -1 goes to -1. So 1 goes to here, -1 goes to there. What about x equals 2? 2 goes to 2, and then we take the 2 and we put it into G, and that gives me back a 4. 3 goes to 1, 1 goes to 1, that gives me out a 5 from G. 4 goes to -2, -2 goes to 3, and then 5 goes to 1, and 1 goes to 5. So if we do F first and then G, these as our starting points, these are ending points. What happens here? Can we do G first and then F? Well, -2 will go to 3, and then if we look for 3 in F, we get 1. So that's okay. -1 goes to -1, and then we're not allowed to do that. So that's not a function, because to be a function, every x has got to have a y, and here x equals -1 doesn't have a y. So you can't make a table for that, because the -1 goes into G and becomes -1, and then you have to look for a -1 in the x table, and there's no x there. Okay, so two functions and form a composite function. If you have a composite function, can you tell what the original two functions were? So here, f of x is a function, and we want to write capital F of x as a composition of two functions. In other words, we want an x, and it's going into a big box. And we want to have in here two smaller boxes, one that's f of x, and then one that's g of x. So x goes in here, comes out of f of x, goes into g of x, and comes out as, oh, I got my letters backwards. F of g of x. This should be g, this should be f, and comes out as f applied to g of x. And in particular, we want that to be, so we sort of need to recognize separate functions here. And in a sense, what we're looking for is where's the parentheses. So one way to look at this is say, well, I've got this thing here, that's a quadratic function. And what have I done to that quadratic function? I've just thrown in absolute values around it. So maybe f of x is the absolute value function. Whatever gets fed into f of x, it just throws absolute value signs around it. So what is it that has the absolute value signs around it? Well, that's whatever the output for G is. And so G of X should be equal to just whatever that function inside the absolute value sign. Right? So the G of X function is inside the F function. X squared plus 3x plus 2 is inside the absolute values. So G of X is what's inside the absolute values. F then is just the absolute values. So F of G of X means take G of X, which is x squared plus 3x plus 2, and throw absolute value bars on it, because that's what X is. And that's the function that we're looking for. What about G of X? Well, G of X is square root of x squared plus 2x plus 5. So what have we done? We've taken a function and we've thrown it into a square root. So we have a function inside a square root. If we want to write this as a composition, this is my inside function. That should be G of X. And what was done to the inside function is what f of x does, and it just took the square root of whatever you give it. So if you give f of x this expression, f of x then just throws a square root on it, and that gives us G of X. So h of x is 1 over square root of x minus 2. There's a number of different ways you can do this. I usually think of it as saying that I've got a function that puts things into the denominator. And I've fed to this something, this function, x minus 2. So there's my inside function. So f of g of x, my inside function would be square root of x minus 2. My outside function, I want it to be that. G of x is the inside function, which is square root of x minus 2. And f of x is the function that just puts things in the denominator. So that's one way to write this. Of course, you could also say that I have a function that puts things in the denominator inside a square root. And then what did I put inside of the square root is x minus 2. So here, f of g of x is still going to be 1 over square root x minus 2. G of x is the inside function. That's my x minus 2. And f of x now is the function that takes things and puts them in the denominator, but also in a square root in the denominator. And if you wanted to get really, really complicated, you could say 1 over square root of x minus 2 is I've got one function that puts things in the denominator. I've got another function that puts things into a square root. So we'll say h of x equals f of g of h of x. We'll actually have three things. H of x is just x minus 2, so that's our inside function. And then we put that inside the square root function. And then we take that and we put it into the function that gives us 1 over x. So functions can be decomposed into simpler bits, and that can happen in a number of different ways, depending on what you're interested in doing. You'll see this again in calculus, where these inside and outside functions help a lot in doing derivatives.